Okay, here this will be a third example of us using the first derivative test to determine if a critical point yields a relative maximum or a relative minimum. So let's take a look at this function f of x. F of x is equal to 3x to the 5/3 minus 15x to the 2/3. And so the first thing, of course, we start to look for critical points. That's going to be where the first derivative is either 0 or undefined. So let's take a first derivative of this. So let's see, so I'll have 3 times 5/3, that'll be 5x to the 5/3 minus 3/3 is 2/3. 5/3 minus 1 minus, let's see, 15 times 2/3, well, 15 divided by 3 is 5, times 2 is 10, so minus 10 times x to the 2/3 minus 1 is 2/3 minus 3/3, negative 1/3. Okay, so we have that. Now let's simplify this a little bit. Notice this could also be written as 5 times x to the 2/3 minus 10 over x to the 1/3. And getting a common denominator, I could multiply this first expression by x to the 1/3 over x to the 1/3. And when I multiply these together, x to the 2/3 times x to the 1/3, add the exponents, we get x to the 3/3. So I'll have 5x minus 10 all over that common denominator of x to the 1/3. And that will be the same thing as 5x minus 10 over the cube root of x. So now this is the first derivative. Well, let's see, we can set it equal to 0 to get a critical point. If I set it equal to 0, I'll have 5x minus 10 over the cube root of x is equal to 0. And that would yield, well, multiplying both sides by the cube root of x. We can do this as long as x is not 0. All right, we get 5x minus 10 is equal to 0. So 5x is equal to 10, x is equal to 2. So I have the first derivative is 0 at 2. All right, so 2 is a critical point. In fact, it's a stationary point. All right, where is 5x minus 10 over the cube root of x? Undefined. And that'll be where the denominator is equal to 0, so where the cube root of x is equal to 0. Cubing both sides, I'll have x is equal to 0 to the 3rd, which is still, of course, 0. So this is going to be undefined when x is equal to 0. So I have two critical points. All right, I have two critical points, f of x I'm sorry, I should say critical points are x is equal to 0 or 2. Now at this first one, notice this one's place where the first derivative was 0. I could use a second derivative test here, but I ask myself then, and this is what I do in those cases, do I really want to take the second derivative of this function? I'm going to end up with the quotient rule and the radical and all that stuff. I don't think I really do. So what I'm going to do is I'm just going to look at the sign of that first derivative. All right, around here, remember we have a critical value where the function is, the derivative I should say, is undefined at 0, and where the derivative is 0 at 2. So these are the only two places where the first derivative can change signs. And so let's take a look at this at, say, x is equal to negative 1. If x is equal to negative 1, we're to the left of 0. Well, if x is negative 1, we'll have negative 5 minus 10, negative 15, so that's a negative number on the top. And we'll have the cube root of negative 1 is negative 1, negative number on the bottom. So, excuse me. So what happens here is that the first derivative is positive. We must be increasing here. Between 0 and 2, say at x equals 1, well, we'll have 5 times 1 minus 10. 5 minus 10 is a negative number, negative 5. And the cube root of 1 is 1, so that's positive. So we have a negative divided by a positive. That's a negative number. Excuse me, we're decreasing there. So we must have a relative max. Here at 0, we're increasing to the left, decreasing to the right. At 2, now we're going to the other side of 2, say at x equals 3. All right, well, if I replace x with 3, I'll get 5 times 3 is 15, minus 10 is 5. That's positive. And 3 to the cube root of 3, well, I don't know exactly what that is, but I know it's positive. So everybody's positive here. So the first derivative is positive, so we must be increasing here. So we must have a relative minimum at x is equal to 2. I think I have these worked out for us in this next part here. And notice here, all right, I didn't actually calculate the relative minimum, but it's about negative at 2. We can go back and compute that. It comes out to be an irrational number. But notice a relative max of 0 at x is equal to 0. The height is 0. And a relative min, the relative min is about negative 14. So the relative min is about negative 14 at x is equal to 2. So there's another example of using the first derivative test. So you can probably find more on the internet if you want.